1,200. We read numbers from left to right. We speak them from left to right. But the moment we are asked to calculate them, we are taught to work backward, from right to left. When you try to picture traditional vertical columns in your head, and then attempt to mentally carry the one, you immediately exhaust your short-term memory. It is simply too much floating data to track at once. The solution is to process the largest place values first. You keep your starting number completely solid, and you break the second number apart. Add the tens block first. 47 plus 30 is 77. Then drop the units. 77 plus 2 is 79. By working from left to right, mathematical processing aligns directly with your brain's natural language pathways. You eliminate the stress of tracking carried digits entirely. The real test of this method comes when you add three-digit numbers. This is typically the exact moment the cognitive load causes people to give up and reach for a calculator. Think of the process as an industrial conveyor belt. Take 538 plus 327. We hold the 538 steady, and we break the 327 into hundreds, tens, and units. Drop the hundreds first. 538 plus 300. Now say the running total aloud. 838. Vocalizing this number is mandatory. Keep that 838 in your mind and drop the tens. Plus 20 is 858. Finally, drop the units. Plus 7 is 865. Notice that you are only ever holding one updated number at a time. A common mistake here is trying to memorize the leftover pieces waiting on the belt. Do not do that. Put all your mental energy into the continuously updating running total. Calculating large numbers in your head does not require an unusually large working memory. It strictly requires processing data sequentially instead of simultaneously. Multiplication requires a slightly different mental action. Instead of stacking numbers, you slice them apart. Take 54 times 7. The trap here is multiplying the 5 by the 7, forgetting that the 5 actually represents 50. You have to slice the number strictly by its place value, 50 and 4. Multiply these separated chunks from left to right. 50 times 7 is 350. 4 times 7 is 28. Add them back together, and you get a safe, manageable 378. Let's apply this slicing technique to a larger problem. 324 times 7. Take a few seconds, slice it up, and read the running total aloud. Here is the mental sequence. 300 times 7 is 2100. 20 times 7 is 140, updating our total to 2240. 4 times 7 is 28. Final total, 2268. Multiplication stops being a test of rote memorization. It becomes a simple act of breaking massive elements into left-aligned, chewable chunks. In daily life, exact decimals rarely matter. Speed and reasonable accuracy are much more valuable when you are making quick decisions. Prioritizing the leftmost digits is a mathematical tool called front-end estimation. Here, you can find a working estimate for $24.47 plus $15.72, simply by grabbing the front values, the 24 and the 15. Let's translate this to a supermarket checkout. You see prices of $4.80, $6.30, and $2.10. Ignore the cents. Look only at the integers. 4 plus 6 plus 2 equals 12. You instantly have a highly confident baseline for your total cost. You already know how to think this way. Division is the only operation taught left to right in traditional schooling, meaning you already possess the cognitive architecture to process math from the front end. Mastering mental math is essentially mastering the art of ignoring insignificant data until the largest, most vital values are handled first. To calculate entirely without pen and paper, you only need to follow 3 non-negotiable rules. 1. Look left. Process the largest place value first. 2. Break it up. Hold your base number solid and split the second number apart. 3. Read aloud. Always vocalize the running total. Becoming a human calculator does not require a genetically superior memory. It simply requires abandoning a broken educational algorithm and finally calculating numbers the way your brain prefers to read them.